Hello and welcome to Mr. Alvarez's virtual chemistry classroom. Today we'll be learning about how to calculate the gram formula mass. Our aim for today is, how can we calculate the gram formula mass of a compound? Before we get started, let's answer 3 do now questions in our do now section. The first question is, what is a mole? Write down everything that you can remember about moles. For question 2, how many of each element are in the molecule glucose, C6H12O6? So count up the number of carbons, number of hydrogens, and the number of oxygens in the molecule glucose, C6H12O6. For the last question, what is the atomic mass of each element rounded to the nearest whole number? So here you're going to take out your chemistry reference tables. You're going to open up to page 9, the periodic table of elements, and write down the masses of carbon, hydrogen, and oxygen rounded to the nearest whole number. No decimals. I'll pause here and I'll step away while you work on this. Welcome back. So hopefully, what is a mole? You should have remembered a couple numbers. For example, earlier in the gas law unit, we talked about 1 mole of gas being 22.4 liters of gas. So 1 mole is equal to 22.4 liters of gas. You may also have remembered that 1 mole is equal to a very large number, 6.02 times 10 to the 23rd particles. For the second question, how many of each element are in the molecule glucose? C6, there are 6 carbons. H12, 12 hydrogens, and O6, 6 oxygens. For question number 3, you should have seen carbon has a mass of 12.011, rounded to 12. That hydrogen has a mass of 1.00, which rounds to 1. And oxygen is 15.9994, which rounds to 16. So, carbon has a mass of 12 grams per mole. Hydrogen, 1 gram per mole. And oxygen, 16 grams per mole. So what is a mole? A mole is the SI base unit used to measure the amount of a substance. And it can be abbreviated as MOL. Now remember, the periodic table of elements is based off of carbon. So if you have a mole of carbon, you have 6.02 times 10 to the 23rd atoms of carbon, and that will have a mass of exactly 12 grams. A mole is a way of counting something. Just as a pair is 2, a dozen is 12, a gross is 144 of something, a mole is 6.02 times 10 to the 23rd. So if I have a mole of carbon, I have 6.02 times 10 to the 23rd atoms of carbon. Same thing with gold. If I have 1 mole of gold, I have 6.02 times 10 to the 23rd atoms of gold. Now the difference is the mass. Carbon has a mass of 12, but a mole of gold would have a mass of 197 grams. Today, we're going to calculate the gram formula mass of different compounds. The gram formula mass, abbreviated GFM, is the mass in grams of 1 mole of any pure substance. Now remember, if we have 1 mole of carbon, we have 12 grams of carbon. Let's see how we can calculate the GFM of other substances. Let's go over the steps required to calculate the gram formula mass of different compounds. Step 1, you're going to write down the symbol of each of the elements in the compound. So write the symbol. So for glucose, C6H12O6, you would write down the C for carbon, the H for hydrogen, and the O for oxygen. Step 2, you're going to write down the masses of each element in the compound. And you're going to round that to the nearest whole number. So you write down the masses of each element in the compound, round it to the nearest whole number. No decimals. Step 3, you multiply the mass of the element by the number of that element in the compound. Remember, glucose, C6H12O6, there were 6 carbons, there were 12 hydrogens, and 6 oxygens. So you'd multiply the mass of carbon by the 6 carbons, you'd multiply the mass of the hydrogen by the 12 hydrogens, and you would multiply the mass of the oxygen by the 6 oxygens. And last but not least, you're going to add up all the masses of the elements in the compound. And that is your final answer. I'll step away so you can finish writing these 4 steps. For our first problem, we're going to find the mass of one oxygen. We're going to follow our 4 steps. Our first step, write down the element symbol for each element in the compound. We just have an element, oxygen, so we'll write down O for oxygen. Dash. Step 2, write down the mass. Well, oxygen has a mass of 15.9994. We're going to round that to the nearest whole number, which is 16. 16 grams per mole. There's only one oxygen, so we're going to multiply it by 1. That's step 3. Multiply the mass of the element by the number of that element in the compound. Once again, it's not a compound, it's an element, so we're going to multiply it by 1. 16 grams per mole with units. That is our final answer. Now, if we had O2, our second problem, same set of steps. First step, write down the symbol for each element in the compound. Write down the mass of each element. Step 2, write down the masses of each element in the compound, round it to the nearest whole number. But this time we have 2 oxygens. So we're going to multiply the mass of the oxygen by 2. 16 times 2 is 32 grams per mole. And that is our final answer. Now the next one's a little bit trickier. We have 2 different compounds, 2 different elements in the compound this time. We have Na and we have Cl. So step 1, we write down the elements in the compound. Now we have to go to the periodic table to find their masses. And we have sodium up here, 22.989777. So we round that to 23 grams per mole. And we have chlorine, which has a mass of 35.453. So round that to 35 grams per mole. Sodium, if you remember, 23 grams per mole. Chlorine, 35 grams per mole. Step 3, multiply the mass of the element by the number of that element in the compound. There is just one Na, and there is just one Cl. 23 times 1 is 23 grams per mole. And 35 times 1 is 35 grams per mole. Now, since we have 2 different elements in this compound, we have to add up their masses. Step 4, add up all the masses of all the elements in the compound. So 23 plus 35 gives us a mass of 58 grams per mole. And we'll box off that final answer. So sodium chloride, NaCl, has a GramFormulaMass of 58 grams per mole. Now here's a compound that you'll need the GFM for multiple times, numerous times before the end of the school year. H2O, water. We'll follow the same set of steps. Step 1, we write down the symbols for each element in the compound. We have hydrogen and oxygen. Step 2, we find the masses of each of these elements. So hydrogen, 1.00794, which rounds to 1 gram per mole. And oxygen, once again, 15.9994, rounds to 16 grams per mole. Now be careful. There are 2 hydrogens and 1 oxygen. So to multiply the mass of hydrogen by 2 for step 3, we're going to multiply the mass of each element by the number of that element in the compound. So 1 times 2 is 2 grams per mole. And there's only one oxygen, so 16 times 1 is 16 grams per mole. Step 4, you add the masses of all the elements in the compound together. 2 plus 16 is 18 grams per mole. The mass, the gram formula mass of water is 18 grams per mole. Let's look at CH4, aka carbon tetrahydride, aka methane. First step, write down the symbols for each element in the compound. Step 2, find the masses. Carbon, nice and big there on the top. We can check it over down here. Carbon, 12.011, 12 grams per mole. And hydrogen, once again, 1.00794, so 1 gram per mole. $12 grams per mole, and 1 gram per mole. CH4 has 1 carbon, so you multiply the 12 by 1, and 4 hydrogens. Multiply the 1 gram per mole times 4. 12 times 1 is 12 grams per mole. 1 times 4, 4 grams per mole. So step 1, write down the symbols. Step 2, write down the masses, round to the nearest whole number. Step 3, multiply the number of that element in the compound. And then finally, step 4, we add them up. 12 plus 4 is 16 grams per mole. The mass of CH4 is 16 grams per mole. Let's take a look at a few questions on your classwork/homework. Problem number 1, NaBr. We're going to follow the same set of steps. Step 1, write down the symbol for each element in the compound. So we have Na, sodium, and Br, bromine. Step 2, we're going to look at the masses of each of these elements on the periodic table. Sodium is 22.98977, round to the nearest whole number. It is 23 grams per mole. And bromine, over here, 79.904, that rounds to 80 grams per mole. There's 1 sodium, since there's no number next to it, and 1 bromine. 23 times 1 is 23 grams per mole. 80 times 1 is 80 grams per mole. And if you add those up, you get 103 grams per mole. Question 2 is a little bit trickier. Now we have 3 elements. We have Pb, which is lead, sulfur, and oxygen. When we find the masses, that's the same. So we have Pb, which is 207.2, so 207 grams per mole. Sulfur, which is 32.065, so that rounds to 32 grams per mole. And once again, oxygen, 15.9994, rounds to 16 grams per mole. There is 1 lead, 1 sulfur, and 4 oxygens. So you multiply 207 times 1, 32 times 1, and 16 times 4. 207 times 1 is just 207 grams per mole. Leave a little space. 32 times 1 is 32 grams per mole. And 16 times 4 is 64 grams per mole. So with a bigger number, when you add it up, 7 plus 2 is 9, plus 4 is 13, you carry the 1. 1 plus 0 is 1, plus 3 is 4, plus 6 is 10, carry the 1. 2 plus 1 is 3. So the gram formula mass of lead sulfate, PbSO4, is 303 grams per mole. Number 3 is a little bit trickier because you have parentheses. Now this 2 here distributes to both the oxygen and the hydrogen. So we have calcium, oxygen, and hydrogen. If we were to look on the periodic table of elements, calcium, element number 20, has a mass of 40.08. Oxygen, we know from before, has a mass of 16. And hydrogen, while we're here, has a mass of 1. So calcium is 40 grams per mole. Oxygen is 16 grams per mole. And hydrogen is 1 gram per mole. 1 calcium, 2 oxygens, because they distribute, and 2 hydrogens. 40 times 1 is 40 grams per mole. 16 times 2 is 32 grams per mole. And 1 times 2 is 2 grams per mole. Add them up. 0 plus 2 plus 2 is 4. 4 plus 3 is 7. 74 grams per mole is the GFM of calcium hydroxide, CaOH2. Before I leave you to practice on your own, let's take a look at number 5. Now number 5 has a lot going on. When you're counting the number of atoms, remember this 2 gets distributed to everything inside the parentheses. So 2 times this imaginary 1, there's 2 nitrogens. 2 times 4 is 8, there's 8 hydrogens. There's an imaginary 1 next to the carbon, and there's a 3 next to the oxygen. So if you did it properly, 2 times 1, 2 nitrogens, 2 times 4, 8 hydrogens. This 3 only goes to the oxygen, so it's 3 oxygens, and of course there's just 1 carbon. Good luck with the rest of your work. Thank you for joining Mr. Alvarez's virtual chemistry classroom. Today we learned how to calculate the gram formula mass, or GFM, of a compound. We did that by following 4 easy steps. Step 1, you write down the symbol for each element in the compound. Step 2, you go to the periodic table of elements and you write down the masses of each element rounded to the nearest whole number. Step 3, you multiply the masses of each element by the number of atoms for that element in the compound. Step 4, you add all the masses of all the elements together. Thank you again for joining Mr. Alvarez's virtual chemistry classroom. I hope you learned something today. Please join us again soon.